So what I thought I would do is give you the honors geometry test as a review, all right? Because your problems are going to be pretty much the same. They may not be exactly the same as this, but no, I'll tell you what. I lied. They will be the same as this, okay? All right, so here we go. Let me change my pen so that it writes on here. And let's change that to that. Okay. So here we go. So this is from the honors geometry, but it's the same stuff. It's the same material. If I was to make you your own standalone Chapter 4 test, it would look very similar to this. So let's go through it. Here we go. We got one class period to do one test. All right, so that's what we're doing. You don't have this test in front of you, so my suggestion, what do you think would be?
Take notes.
Not just take notes, but to do what? Yeah, write down every single problem, okay? Because you're going to see these problems on the midterm, all right? I'm basically handing you the midterm exam right now, at least half of it. So I would write these down, draw the picture, write all the stuff. We're going to go through every one of these. So I'm going to go a little fast, but if you need me to slow down, you can always go to the YouTube page and watch the video. All right, here we go. So it says find angle T and then find angle SRQ. So let's do angle T first, that one right there. Well, what do we know? We got a triangle, and we got three angles in a triangle. Somebody tell me what those three angles do in a triangle. Any triangle, the three angles do what? They add up to 180. So what are we going to do with those three angles? Add them up and set them equal to 180. Now, they're not just regular numbers, are they? They got x's in them, but that's all right. We can add x's together. So let's do that. Let's add them. Let's add them in our head. 2x plus 2x is what? 4x plus another x is 5x. So 5x, if I add them all up, it's 5x. What's it equal? 180. Okay? Everybody with me? How do I get x by itself? Divide by 5. Somebody do that for me. What's that? Is it like 27 or something? Or somebody do it. 36? Thank you. 36. Is that the answer for number one? It's not, because this angle is what? 2 times x. So what's this angle right here then? 2 times 36. I know what that is. 2 times 36 is what? 72. Okay? Everybody with me on that? All right. So that's the answer to number one. What about number two? SRQ. Let's find SRQ. SRQ is this big obtuse angle right there. That's what we got to figure out. A couple ways you could do it. Let's do it like this. This is 2x. It's 72. So what's this angle right here? That's also 72, isn't it? So how do I find this angle right here, this big obtuse angle? Let's put it away. There's no eating in here. So what do I do? Somebody say it. That's it. So it's 180 minus 72. What's that? 108? And that's your answer right there. 108. Okay? You could write it in there. That wasn't too hard, was it? All right, as long as you know that the three angles add up to 180, the rest is, I think, fairly easy. What about this one? Same kind of thing. All right, almost the same problem. All right, so we got three angles in a triangle. What do? They add up to 180, so let's add them up. Can we add them up in our head or not? Let's add up all the x's. I got one x, got another x, got another x. How many x's do I have? 3x. Let's add the numbers. I got a negative 20, right, because it's minus 20. And then I got a minus 40. What's negative 20 minus 40? Negative 60. Now, what do? I just added them up. What do? They add up to what? 180. You with me? All right. Now the math is a little bit different than this, but it's pretty close. Add a 60. Right, I'll just do that in my head. Add a 60 to this, I get 240. Divide by 3, I get 80. Is that my answer, though? It's not, because they asked for angle A. Angle A is x minus 40. Well, I just found x, which is 80. I'm sorry, not 40. That's the next one. X minus 20. So now I've got 80 minus 20. So what's angle A? 60. That's pretty easy, isn't it? So angle A is 60 degrees. Angle C is just as easy. Again, it's x minus 40. X we found out to be 80. So 80 minus 40 is 40. That's angle C. And those are the two things that they ask for. It is. We good with that? Okay. Now, we had some stuff in chapter 4 like this. These triangles, they are congruent, but we got to say why are they congruent and which triangles are congruent. Remember doing this? It's been a little while. Okay, you probably had this on the quiz, right? Should have gone over that quiz, shouldn't I? Forgot about that. That's all right. We'll do this. This is what's going to be on the test anyway, so there we go. So why are these two triangles congruent to each other? Where's the other angle? I don't see the angle. It's this one where the X is, right? That one right there and that one right there. Okay, they're equal to each other because they're called vertical angles. You're writing all this down, right? I'm giving you the whole entire test and you're just sitting there with nothing on your desk. It doesn't make sense to me. To me, if I was going to hand you a test and I said you're going to take a test that looks exactly like this, I would take that test, wouldn't you? You said recorder, right? So you're just going to rely on that? You're not going to do anything in class? Why? What else you got to do? What else is there possibly that you could be doing right now? There's nothing else. I would write it down. It's up to you. I can't force you to do it. I mean, I guess I could force you to do it, but I'm not going to. It's up to you. It doesn't make sense to me that you wouldn't take notes when I'm giving you everything that's going to be on the test here. All right, enough of that. Here we go. These triangles are congruent because of angle, side, angle. There's an angle, there's a side, there's an angle. So that's part of it because it says name the postulate that justifies why they are congruent. That's the angle, side, angle part of it. Everybody see that? Name the postulate that justifies why they're congruent. So they are congruent because of angle, side, angle. But it asks for something else here in the problem, doesn't it? It says for the following pair of triangles, write a valid congruence statement. A congruence statement. What does that mean? That means you have to say which triangles are congruent to each other. So let's name them. Let's name this triangle on the left right here. What would you want to name it? WVX. All right. WVX. And it's congruent to, remember the congruent symbol? It's an equal side with a little squiggly on top. It's congruent to this triangle right here. Now, the key to this is to make sure that the points line up. All right. So the corresponding points over here have to match up with the corresponding points over here. So if I go WVX, let's do the W first. Which angle over here matches up with the W over here? Does it? Just because it's up on top? Why the Y? WHY the Y? Because this has one arc and this has one arc. So what matches up with the W over here? The Y does. Everybody see that? That's really important. Okay? What about the V? Over here, this V right here. Which one over here matches up with the angle V? How do you know the Z? Right, this one is the one, it's the only one that doesn't have an arc, okay? So this one doesn't have an arc, so the V and the Z match up. So V is second here, Z is second here. Then, of course, what else is left over? I got a Y, I got a Z, and I got the X. All right, and that is your answer. It's a two-part answer. Okay, this is the congruent statement, and this right here is the postulate that justifies why they're congruent. So these are the triangles that are congruent. This is why. If you get either one of them wrong, the problem is wrong. Everybody understand that? You got to get them both right. Let's do this one. I got a side. I got an angle. What else do I have? I got a side. Which side? Give me the actual side, like with the points and stuff. AC, very good. So AC is equal to itself. We call that the reflexive property. This is because of vertical angles are equal. This is because of the reflexive property. All right? So now, I always like to do the postulate first. Why are these triangles congruent to each other? Because of side, what? Angle, side. So it's side, angle, side. Side, angle, side. That's the postulate that justifies why they're congruent. Let's write the congruent statement, okay? So I'll write it right here. Triangle. What do you want to call this one down here? ADC? All right. It doesn't matter what order you put that first one. I could call it ACD, could call it DAC, CDA, whatever. but I decided to call it ADC. So if I call this one ADC, I have to call this one something, okay? And it's got to be specific. So which one matches up with the A on this triangle right here? The C, because the A has the one arc. Do you see it? And the C has the one arc. So the C is going to go first. It's an ugly looking triangle right there, but you get the idea. So C goes first. Then D. Which one over here matches up with the D? If you're not sure, here's a trick. Look at angle D. Look what side angle D is opposite. It's opposite this AC, isn't it? Everybody see that? So over here, which side, or which angle is opposite this side right here? Angle B. So angle D and angle B have got to be the same. You see that? Because angle D is opposite this side with two arcs, and this angle right here is opposite this side with two arcs. So they're the ones that match up. So sometimes that's a little tricky. So instead of D, we put what? B. And what's the other one that's left over? That's always the easy one, A. So it's got to be in that order. Now, again, you can make that first one a different order. You can make it DAC if you wanted to, or CDA. It doesn't matter. But these have to match up. The A and the C have to match up. The D and the B, the C and the A. Everybody got that? Okay, that's really, really important. Let me answer this email because it's about kids in this class. All right, that's done. All right, one more. This is actually the easiest one, I think. Here we go. Why are these triangles congruent to each other? I got a side, and I got what? I got another side. I got this one that's shared by both of them. That's called reflexive property. All right, so they're congruent because of side, side, side. Now let's write the triangles. Let's slide it in here. Let's call this triangle something. I don't know. Let's call it QRT. QRT. Now again, doesn't matter which one you call the left triangle. I mean, you got to have Q, R, and T in it, but you can change the order. It doesn't matter. But this one has to be in a proper order. So if I go Q, then I went R, then I went T, what's it going to be over here? This one's kind of easy because this one kind of like folds on itself, right? And you can see which ones match up. So which ones match up with the Q? Go ahead, Jason. Yeah, QST, exactly. It'd be QST. Because the S, because look, the R is opposite the three arcs. The S is opposite the three arcs. Q is opposite the two arcs. Q is opposite the two arcs. Okay? And then this T down here is opposite the 1. This T down here is opposite the 1. All right? So you can see that it works out. We good? All right, let's keep going. Find the measure of each angle. Well, where are the angles? There's angle 1, there's angle 2, and there's angle 3. And we got to find all three of those angles. Where in the world do we start? It's not 232, it's 132. Does it look like a 2? Yeah, it does because it's right in that. You know, I can't move it. But that's a 1, sorry. It does look like a 2 up there. But on the screen here, it looks like a 1. So that's 132. So where do I start? I could find this angle, couldn't I? By 3? No, I wouldn't divide it by 3. Everybody look up here. It is an isosceles triangle, and that means that this angle right here and this angle right here are equal to each other. Guys, how do I find this angle right here? They form a straight line, right? These two angles form a straight line. So what do we know about two angles that form a straight line? They add up to 180 degrees. So how do I find this angle right here? Don't divide anything. Subtract 132 from 180, right? Because these two make up 180. If I take this away, this is what's left over, right? If I take 132 away from 180, then I'm left over with this part right here. It's like money. If I have $180 and you give me 132, how much do you have left? 180 minus 132. Make sense? It's the exact same situation here. So what is 180 minus 132? That would be what, 48? Okay, not 148, just 48. So this angle right here is 48 degrees. But you're saying, Mr. Hamrick, they don't even ask for that angle. Who cares what that angle is? Well, I think it is important because we're going to eventually have to find angle 1, correct? So I know this angle. I also know this angle right here, this little red one, because it's 48 as well. How do I know that? Because it's an isosceles triangle, right? They're two equal sides. That means the opposite angles are equal to each other. So if this is 48, then this is 48. Okay? And now, exactly right. You're on the right track. Now I got to find angle 1. So what do? All three of these add up to 180, don't they? All right? And so I can go 48 plus 48, which is 96. And then I take that away from 180. All right? And what's that? That's a 4 and that's an 8. So this would be 84 degrees. So angle 1 is 84 degrees. Exactly. Look at this. Angle 2 is another angle we have to find, isn't it? It's right next to that 48. Well, we had something else earlier that was right next to the 48. We had this 132. So I don't even really have to do any math on that, do I? Okay, I can just look at that and I say, oh, this is right next to the 48. That's 132. Well, this one's right next to the 48. So that's got to be 132. There's number 9. We good? Now, angle 3 is a little bit trickier. Now, again, I know angle 2, don't I? Oops. There it is. So I know angle 2 is 132 degrees. 132. What I can do is this. This triangle right here has two equal sides as well. So what must be true about this angle 3 and this angle down here? They have to be equal to each other. How does that help us? Well, all three of those angles add up to what? 180. So if I take 180 minus 132, which I've already done over here, right? So these two angles, they're not each 48 degrees, but they both add up to 48 degrees, and they're both exactly the same. So what two of the same numbers adds up to 48? 24. So angle 3 is 24. Everybody see that? Okay. This probably, out of all the problems on the chapter 4 part, is probably the one where you have to think about the most. Okay? But yeah, it's not that hard. It's almost like a little puzzle you're trying to solve, right? You find one part. You ever do a puzzle, right? Put puzzle pieces together. You start putting more together, and then it starts making more sense, right? And you kind of see what it's looking like. That's exactly what this is, okay? So you start here at the number they give you, and then you just start finding stuff. You're like, okay, I can find this one. Oh, these two sides are equal. That means I could find these two, right? And then you just keep on going. It all just builds on itself. Because this is right next. See this angle and this angle right here? They're right next to each other. They make 180 degrees. So if this was 48, 180 minus 48 is 132. But you could also look at it like this, that this 48 was right next to this 132, which made a right angle. So if this is 48, this has to be 132 as well. Yes? Yeah, as far as showing the work, you mean? Yeah, right. You don't need to. Right. To find this was 132 because you went 180 minus 48. You already did it over here. So yeah, just write it down. Yeah. Do you remember we had that right angle stuff? Okay. I'm actually not going to put this on the midterm. I told the honors kids I wouldn't put it on there, so I won't put it on yours, okay? It's not that it's really hard. It's just I was running out of time, and I could use the time now too. So don't worry about 11, 12, and 13. All right? Let's keep going. These look like they're difficult, but they're actually really easy. If you can remember. Do you remember this? Let's see. This was right before the break, right? Didn't you take a quiz a little bit before the break? Okay, so look. This right here, look at C. This segment and this segment are equal, so C is the midpoint. Do you agree? This segment and this segment are equal, so what? D is the midpoint. I have a segment that connects the midpoints you remember what we call that? Mid-segment. That's right. Mid because it hits the middle, the midpoint. It's a segment because it's a segment. Now, we learned back then, I know it's been a couple weeks, but we learned that the mid-segment, the length of it, is half of the third side. Everybody got it? Or the third side is twice as big as the mid-segment. We also learned that they're parallel to each other. Okay, the fact that they're parallel doesn't really matter as far as this particular problem goes, but they are parallel. So this CD and XZ are parallel to each other. So if I know what this is, the question says find XZ, which is this bottom right here. It's very easy. What do? You just double it. That's right. Multiply by 2. So that's 14. So XZ is 14. Very, very easy. Took up a lot of real estate on my test to draw the triangle and all that, but it's actually very, very simple. This is just as easy. Look, find VU. Where's VU? It's this one right here. And again, VU is the mid-segment. Agreed? Because it hits the midpoints. That's why I put these little arcs right there, or these little tick marks right here. If I didn't put the tick marks, you could not assume that they're the midpoint. All right? But it is the midpoint. So this time, they don't give you the mid-segment. They give you the third side. So how do I find the mid-segment? Just divide it by 2 this time. That's right. This is half of this. So that would be 12. It's as easy as that. Okay? Now, with that being said, look at number 16. Which one is the longer side? Is it SQ or is it ZY? SQ, right, because the midpoint, that's definitely shorter than this one. Agreed? So SQ is twice as big as what? ZY. You follow me? So SQ is or equals 2 times whatever ZY is. So what's SQ? 3x minus 8. That is, or it's equal to what? Twice this mid-segment. So 2 times, I put a parentheses here because it's multiplied by 2 things here. X plus 2. That's the geometry. That's the part that you really need to know. The rest is just work, okay? It's just algebra. But that's the geometry. To be able to understand that the third side, right, the long side, is twice as big as the mid-segment. You got that? Okay, now let's do the work, okay? Let's do it kind of quick, though. It's 3x minus 8, distribute, right? We've done this before. I don't need to reteach that. Let's get the x's on the left-hand side, so subtract a 2x from both sides. That gives us an x. You can do that in your head, can't you? Let's add the 8 to both sides. What's that give us over here? Gives us 12. Is that my answer? Do I circle it? Do I circle that? It's not my answer, because what are they asking for? YZ. So I take the x and I plug it in, right? So what's YZ going to be? 14, because it's 12 plus 2. I know it's kind of small up there. That's x plus 2. All right, so it's 12 plus 2, and so that is 14. Yes, sir. Yes. We good with that? Man, we're almost done. And we still got 15 minutes left. We're cruising. On the this is pretty easy test. I think I made it way too easy. I think I had on my honors class that took this test, I think I had more than half the people get 100 on it. Not just an A, but an actual 100. So that kind of tells me I got to make it a little bit tougher next year. I didn't say for you. I said next year. I said next year. Right. It's not. I'm not going to make it. Okay, let's take a look at this. Here we go. We just did this the other day, didn't we? Was it yesterday? Okay, we did slope. All right. So let's take a look. Now, do you remember what I said about the mid-segment and the third side? I said the third side is twice as big as the mid-segment, but I also said what else? What else did I say? That the two segments are also what to each other? Parallel to each other. That's going to come in to play on this problem. All right? I'll show you a kind of an easier way to do this one. So it says, find the slope of DE. Well, the problem is, I don't know what that point is for D, and I don't know what that point is for E. Now, I could do what, do you think? Remember what D is. D is the what of that side? It's the midpoint. Well, it's the midpoint. Point D is the midpoint. What is point E of this side? That's the midpoint. So I could find the midpoints, couldn't I? So I could find the midpoint here, and then I could find the slope between those two. But there's an easier way, okay? There's a little trick, a little hack, as some people say, all right? Like a life hack. This is geometry hack. Now look, remember, slope. It says find the slope of DE and the slope of AB. Look at AB. I actually know the points on AB now, don't I? All right? So if I found the slope of AB, tell me something about the slope of DE. It's what? It's no. We're talking slopes. We're not talking how long the lengths are. That's the next one. That's the length. What's true about the slopes of lines that are parallel to each other? They're the same. That's right. Because two lines that go in the same direction have the same slope. They're slanted the same exact way, aren't they? You follow me? So look, instead of finding the midpoint here, and then finding the slope, all we have to do is find the slope of AB, which they're going to ask you anyway, aren't they? All right? So let's find the slope of AB. We did this yesterday. It shouldn't be that hard. The slope is, we subtract the y's and put them on top, subtract the x's and put them on the bottom. So let's find the slope of AB, and then the slope of DE is going to be the exact same thing. So really, I only have to do work for one problem. The other one's going to be the same. Problem is, if you mess up the slope of AB, and then you write the same thing for DE, you get two problems wrong just for making one mistake. So that would be unfortunate, but let's get it right. Let's not get it wrong, okay? So let's find the slope of AB. How do we do that? Subtract the y's from each other. Does it matter what order we subtract them? Nope, as long as you subtract the x's in the same order. You could go -1 minus 5, or you could go what? 5 minus -1. Which one would you rather do? That's what I would do. Either way would work, but I would do it this way. Now, if I went the top one minus the bottom one, I got to do the same thing for the x's. Notice, I put the y's on top, right? The y goes on top, the x goes on the bottom. Now I'll do the x's. 6 minus what? -4. It's not just 6 minus 4, it's 6 minus -4, because that's a negative. And now we just work it out. That's easy. 5 minus -1, what's that? 6. And then 6 minus -4 is, okay, we don't keep it 6 over 10. We always reduce fractions, always, always, always. So it's 3 over 5. And it's positive, isn't it? So the slope of AB is 3/5. Without doing any work at all, what's the slope of DE? It's 3/5. Because the slopes are the same on a mid-segment and that third side. Okay? Now look at the next problem. The next problem is a little different. This says not to find the slope, but find the what? The length. Now again, to find DE, I would have to know the midpoint. I mean, I could find it. It'd be all right. I could do that if I wanted to, but it's too much work. All right? I'm not going to do that right now. What I'm going to do is I'm going to find the length of AB first, because I know the 2 points, don't I? So I'm going to find the length of AB. Once I get that length, what's DE going to be? Is it going to be the same? It's going to be half of it. That's right. So whatever I get for AB right here, I just take half of it, and that's what my DE is going to be. So really, I only have to do that distance formula just one time. And that was my next question, actually. How do I find the length if I know 2 points? I use the what? The distance formula. We did this yesterday. All right, so hopefully you remember it. If you don't, you'll probably be guaranteed to get at least 2 problems wrong on the test. Unless you're good at guessing and if you remember all the answers. But to remember 40 answers, that's a tough call, all right? That's tough to remember all 40. And you don't even know which 40 I'm going to pick, right? Because I had several different options on another test on Chapter 3. So you're not really sure which ones I'm going to pick and which ones I'm not going to pick. So I would just know how to do them. So what do? We subtract the x's from each other. So basically we're doing this kind of the same thing as we did over here, except we're putting in the distance formula. So let's subtract the x's. 6 minus negative 4. Subtract the y's. 5 minus negative 1. All right? Square root. Let's do this. 6 minus negative 4 is 10. And then what do we have to do with that? Square it. 5 minus negative 1, what's that? 6. And what do we have to do with that? Square that. All right? And now let's just do some math. What's 10 squared? 100. And then this is 36. So my answer is the square root of 136. Now, if this was an Algebra 2 class or even an Algebra 1 class and I was teaching square roots, you can simplify the square root of 136. I'm not going to make you do that since this is geometry, okay? If it was an Algebra 1 class or an Algebra 2 class and you didn't simplify this, then I'd mark it wrong. But this is fine. I'm good with this, all right? What did we just find? We found the length of AB. So what is it? It's the square root of 136. Don't put it into a calculator and get a decimal number. Everybody hear me? Okay, just keep it the square root of 136. Now, to find DE, do I have to go through all that again? Just divide it by 2. So how do I do that? I'll show you. It's the square root of 136 over 2. And that's how you do it. Don't take 136 and divide it by 2 because it's not a 136. It's a square root of 136. Okay? So you don't just take 136 divided by 2. All right? Just leave it like this. Everybody see that? Just leave it like that. Leave it like that. So AB, number 20, would be the square root of 136. And then DE, number 19, would be the square root of 136 over 2. Okay? And there you go. That's the test. Did you recognize any of these from the quiz? We got 5 minutes. Let's find the quiz. Let's see if I have it. Logan, you have a question? Is it on what? On RenWeb? Like, no, I did not upload these to RenWeb. It's go to YouTube though and watch it on YouTube. Let's see. I know I didn't put any worksheets or anything on RenWeb. Oh, that's honors. I don't want honors. I want CP. Let's see. Quiz. Oh, here they are. 4.1 to 4.5, right? There we go. Yeah. Do you recognize this quiz? Guys, we're not finished yet. I thought we understood. Let me export it. All right. Should show up right here. There we go. All right, just give me a second while I do this. Let me just chuck this to here. Okay, here's the quiz that you guys actually did take. And let's see if anything looks familiar. I made your quiz kind of easy. All right, let's take a look. Let's go. We got 5 minutes, okay? So let's go through this. Look at number 1. Classified by the measure, or the angle measure and the side length. So what kind of a triangle is this by the angles? It's not just a right angle, it's a what? It's a right triangle. Okay, so it's a right triangle. What about the sides? Are the sides equal to each other? Are 2 of the sides equal to each other? Are none of the sides equal to each other? None of them. What do we call that? What do we call a triangle and none of the sides are equal to each other? It's a scalene. That's right. It's a weird word. We don't use it that often, but that's what it's called. All right, what about this one? About the angles, the angle measure. What's true about all 3 of these angles? They're all equal to each other. How do I know they're all equal? Nothing's marked. Well, because they're opposite all 3 equal sides, so this, and this are equal. What do we call a triangle that has all equal angles? It's not lateral. It's angular. It's the angles. It's equiangular. Since listen to this. Since I skipped like 3 or 4 of those problems from the test, remember that? I'll probably use some of these to throw on there. So these could be good possibilities. Okay, what about the side length? All 3 sides are equal. What would I call this? Equilateral. That's right. Equilateral. Now, somebody on the quiz, or several people on the quiz, put isosceles. Technically, that's true. Why is that true? Because isosceles means at least 2 of the sides are equal. Does this have at least 2 sides equal? Yeah. So I would give you isosceles, but I was looking more for equilateral. All right. What about this one right here? We kind of did something like this. It wasn't the same numbers, but we did something like this on that test. Angle A. How do I find angle A right here? Well, what do? Add these up. So what's 65 and 65? 130. Then what does that mean angle A is 130? No. What do I have to do with that 130? Take it away from 180. What's 180 minus 130 in your head? How about 50? Okay. So that would be 50. What about ACD? Now watch. ACD, this one right here. There's 2 ways you could do this. Did you know that? You could. We've talked about this a couple times today already. So you could go 180 minus 65, which is 115. Everybody see that? Or you could do this. Since you already found this to be 50, you could just add 50 and 65. Do you remember doing that? The external angle is equal to the sum of the remote interior angles. Remember that? Okay, so if I just add those, that's 115. Either way, I still get 115, don't I? Isn't that nice? Do these look familiar? Yeah, we did those already. I won't give you this stuff, but we did this. These are different, so let's just do them. First of all, it says write a valid congruent statement. I even put it in bold. And then name the postulate. Let's do the postulate first. Why are these congruent to each other? This is good practice, Logan. Side angle side, very good. So that would go second. Some of you guys mixed it up. Look, it asks for this first, and it asks for this second. All right, I didn't mark it wrong if you put them in different spots, but you should put the reason on the second line right here. To me, that makes sense. Congruent statement. Let's do that. So let's call this. What do you want to call that one? Yeah, ABC. And then what over here? If I go ABC, now look, we flip this and turn it around, so it might not be so easy to see. So where do we look? We look to see what side it's opposite. What's opposite angle A? Well, F is not opposite angle A. There's a side that's opposite angle A. What is it? It's the one with 2 arcs, right? So what angle is opposite the one with 2 arcs over here? Angle F. So F right there. What about B? B is the one with the little arc, and so the little arc over here is E. So that's E, and then D. All right, that's enough.